Class 10, Chapter 1, Real Numbers, Exercise 1.4, Question number 3. The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factors of q? The numbers are 43.1234567891, 0.1201200120000120000 and so on. 43.123456789, where 123456789 repeats itself. We know that a rational number, say x, can be represented in the form p by q, where p and q are co-primes and q is not equal to 0, whereas an irrational number cannot be expressed in the form p by q. Rational numbers are of two types, which are terminating decimal expansion and a non-terminating repeating decimal expansion. In a rational number of the form p by q, a terminating decimal expansion has q in the form 2 to the power m into 5 to the power n only, which means it contains either the prime factors 2 or 5. Here, m and n are non-negative integers, which means m and n can take the values 0, 1, 2, 3 and so on. We can say that q as a product of its prime factors can be represented as 2 to the power m into 5 to the power n, whereas in a non-terminating repeating decimal expansion, q cannot be expressed in the form 2 to the power m into 5 to the power n. Now let us understand what can be the decimal expansion of an irrational number. An irrational number always has a non-terminating, non-repeating decimal expansion. Now, let us consider the numbers given to us in the question and try to find whether they are rational or irrational, and let's see what we can conclude about the prime factors of q if the number is in the form of p by q. Taking the first number, which is 43.123456789, we can see that this is a terminating decimal expansion, which means it is a rational number, and we can represent it in the form p by q, where q is not equal to 0. Let us see how we can represent this number as p by q. We can write it in the following manner. We can see that the denominator is a power of 10. So we can write the denominator as 10 to the power 9 because it has 9 zeros. Now 10 to the power 9 can be further written as 2 into 5 to the power 9, which can be further written as 2 to the power 9 into 5 to the power 9. So we can say that the denominator q can be represented in the form 2 to the power m into 5 to the power n, and hence we can say that the prime factors of q are in the form 2 to the power m into 5 to the power n, or q contains the prime factors 2 and 5 only. Moving on to the next number, which is 0.120, 1200, 12000, 1200000 and so on. We can see that this is a non-terminating, non-repeating decimal expansion, which means that this number is an irrational number and it cannot be expressed in the form p by q. Hence, we cannot say anything about q because no such number q exists. Moving on to the next number, which is 43.123456789, where 123456789 repeats itself, we can see that this number is a non-terminating repeating decimal expansion, which means this must be a rational number. Since it is a rational number, it can be represented in the form p by q. But since it is a non-terminating decimal expansion, q could not be of the form 2 to the power m into 5 to the power n. Therefore, we can say that the prime factors of q cannot be expressed in the form 2 to the power m into 5 to the power n.